Hello guys, let's solve this Leetcode challenge 2962 medium problem. Here a nums array is given to us and a k value is given to us. We have to calculate all the subarrays which have a maximum element k, at least k number of times. So first we would calculate the max element and then every subarray we would take out for brute force, get the max value and count in that particular subarray how many times the max element is present, and if it is greater than equal to k, we would put a check. We would increment count by 1, and that's how we get the time complexity as n cube and space complexity as 1. But this is brute force solution only will work for small inputs. Let's see a better approach, which is sliding window. Here we would create a frequency map, expand if frequency of max element is less than k, and shrink if invalid, that is greater than equal to k. So here left and right are initialized at 0, and then right would move ahead. We would form a window. Here frequency of 1 is 0 less than k, expand. Here frequency of 3 is 1 less than k, expand. Here frequency of 3 is 1 again, expand. Frequency of 3 is now 2 here. So we got our window here, valid window. We would count all the subarrays possible from this and ahead of this. Like 1, 3, 2, 3 is one subarray. If we extend this, still we would have least amount of k max values, that is 2, because if the smaller subarray has 2 max elements, the bigger subarray would also have at least 2 the max element frequency 3. So that is why whatever elements here are remaining, we would, for those subarray calculation, we would use this formula n minus r. We would increment our count by this. So here n is 5 and r is 0, 1, 2, 3. 3. 5 minus 3, 2. So we would get 1, 3, 2, 3 and 1, 3, 2, 3, 3. These two subarrays are calculated here itself. Now we would try to shrink and see if any smaller subarray has this property of frequency is equal to 2. So here also frequency of 3 is 2. We are getting the subarray. We will count all the extensions possible for this subarray. Here also we will get two subarrays, 3, 2, 3 and 3, 2, 3, 3. Now again we will shrink and see if any smaller size window can have frequency as the required 2 of 3. Here it is 1. So we would stop here and now we would expand the window again. Now it has become 2, 3, 3. Again we got 1 from here, but the right index has reached here. So n minus r would be 1, which would be this subarray itself, 2, 3, 3. So that count would be added. Now again we would try to shrink and see if any smaller size sub window can have the required condition. Here this also has the required 3 element 2 times. So we would again shrink, and now the window size is 1. It has become invalid, so we would expand it again. And as right was on the last index, it would exit the loop if it was here now. So our Dry run has stopped now. And let's see, 2, 2, 4, 5, 6. 6 is the count of the subarrays having the condition of max element at least 2 times. Now let's go to the best approach. As we observed in this dry run, we are only checking frequency of max element every time. So we'll keep a variable for that and maintain our count variable 2 to check the current frequency of max element in current window. So this is our global max value. This count is count of that max value in our current window. Left and answer would be initialized to 0. This is our nums. I'm taking another example. K is 1. Your max element value is 2. Its count is 0 initially. We would start left and right from the initial first element. Now the one size window, we would check count. If count is less than k, we would expand. Count is 0 here, so we would expand. Now this one too. Count is 1, which is equal to k. So we would increment answer by n minus right. We saw that how in the better approach, we saw how this calculation came out to be answer equal to n minus right. Now again we would shrink because we want to find even smaller subarrays which satisfy the condition. Here we got the single element 2, count is 1. Again we would think if shrinking is possible, but left is smaller than equal to right, and if we shift left further it would be greater than right, so we cannot move ahead further. We cannot shrink it further. That's why our right would get implemented now. And left is at 1, right is at 1. Count of 2 is 0 here. We would expand, but now right would go out of the loop, so we would exit the main loop and return the answer. This is what we get as the answer. This is it for today. Let's meet tomorrow. Thank you.